Okay, children, I will explain once more. So, first, uniformly charged sheet, positively charged thin sheet, you can see. How is it kept? YZ plane. It is kept in YZ plane. As it is positively charged, what is the direction of electric field, children? Megha, what is the direction of electric field? This is a positively charged sheet. Outwards or inwards? Electric field, Megha. Outwards. Positive charge, it is outwards. Negative charge, it is inwards. Okay. And at a equal distance from this sheet, equal distance from this sheet, the electric field will be same. Understand? Equal distance. So, you take a small area of this sheet. Surface charge density is sigma. If you consider a small area dA, sigma into dA will be the charge enclosed by this Gaussian surface. What is the Gaussian surface taken here? Cylinder. Cylinder is the Gaussian surface taken here. So, where we have to find the electric field density? At P. We have to find electric field density at P due to this charge distribution. Charge is distributed over a thin sheet. Okay. And here Gaussian surface is taken, and the Gaussian surface is having three surfaces, two plane surface and one curved surface. I will show this
one of the
video.
plane faces of which passes through P, and as such, the plane face is parallel to the plane of the sheet of charge. The point P is at a distance x from the sheet of charge. The point P lies on the circular surface of the Gaussian cylinder. We see that the cylinder extends to the other side of the sheet of charge, and the plane faces of the cylinder are equidistant from the plane sheet of charge.
Two
Let
plane
the plane
surface.
circular faces of the cylinder be marked as 1 and 2, and the curved surface of the cylinder be 3.
Understood, children? Three surfaces, understood? Three surfaces, one plane surface, two second plane surface, and the third one is the curved surface. Tell me. Okay. 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 So, okay. You can see a cylinder which is having three surfaces. First, surface 1 flat surface, surface 2 also flat surface, and surface 3 is the curved surface of the cylinder. Okay. And what is the flux passing through these three surfaces? That you have to find out and you have to add. Then you will get the total flux passing through the Gaussian surface. So you can see that how
Total electric flux phi through the Gaussian cylinder is the sum of the electric flux phi 1, phi 2, and phi 3 through the surfaces 1, 2, and 3 respectively of the Gaussian cylinder. Let this be equation 1.
Okay, I will ask you next question. So, you know it is a positively charged sheet. So, electric field is outwards. So, if you take a point here, we draw electric field line. If you draw an electric field line, it will be outwards. And if you draw a normal, it will be also in the same direction, normal to this surface. This is a flat surface. If you draw a normal, it will be normal to this. What is the angle between electric field and area vector, children? What is the angle between electric field and normal? Adityan, tell. What is the angle between electric field and normal? Adityan? No answer. Abhinav, tell what is the angle between electric field and normal? Abhinav?
90.
What is the angle between electric 90 ആണോ? ഇവിടെ ഞാൻ പറയുന്നത് ശ്രദ്ധിച്ച് കേൾക്കാം കേട്ടാ. ഇലക്ട്രിക് ഫീൽഡ് എന്ന് പറയുമ്പോൾ ഇങ്ങനെ പോകും കേട്ടാ, ഔട്ട്വേർഡ്സ്. ഇനി നോർമൽ എന്ന് പറഞ്ഞാൽ പ്ലെയിൻ സർഫസിന് നോർമൽ എന്ന് പറഞ്ഞാൽ ഇങ്ങനെയാണ് പോകണം. അപ്പം അത് രണ്ടും തമ്മിലുള്ള ആംഗിൾ എന്തായിരിക്കും?
0 degree.
0 ഡിഗ്രി ആയിരിക്കും കേട്ടാ. അപ്പം പ്ലെയിൻ സർഫസിൽ ഇവിടെ നമുക്ക് 0 ഡിഗ്രി. അപ്പം ഫ്ലക്സ് എന്ന് പറയുമ്പോൾ EDS cos 0 വരും. EDS cos 0ന്റെ വാല്യൂ എന്താണ്? വാട്ട് ഇസ് ദ വാല്യൂ ഓഫ് cos 0? വാട്ട് ഇസ് ദ വാല്യൂ ഓഫ് cos 0? പിന്നെ 1. അപ്പം E ഇൻറ്റു DA, ഇവിടെ ഏരിയ DA എന്നാണ് എടുക്കുന്നത്, EDA എന്ന് വരും. അതുമാതിരി ഫോർ ദിസ് സർഫസ് ഓൾസോ വി ഗെറ്റ് E ഇൻറ്റു DA. അപ്പം 2 ഇൻറ്റു E ഇൻറ്റു DA ഇൻ്റഗ്രൽ smaller area is this one, the whole area it will be A. അപ്പോൾ E into A എന്ന് വരും. അപ്പോൾ ഫ്ലക്സ് 1 ഉണ്ട്, ഫ്ലക്സ് 2. Flux, what about flux 3, children? What is the flux passing through the curved surface? Normal will be like this. Electric will be like this. What is the angle? Children, tell. For a curved surface, what is the flux?
90.
Angle will be 90. What will be the flux then?
1.
Cos 90. 0. Cos 90 0 അല്ലേ? EDS cos 90. Cos 90 0. So flux through the curved surface will be 0. But there will be flux through the flat surfaces. E into A, E into A. 2 into E into A. We will get integrating that. So you can see the steps here.
Let's first calculate the electric flux phi 1 through surface 1. According to Gauss law, we can write phi 1 equal to integral d phi 1. Here, d phi 1 is the electric flux through a small element of area dA on surface 1. d phi 1 is equal to E dot dA, where E is the electric field strength at the local element considered, and dA is the area vector with respect to the local element considered.
Can you hear that sound now? Video sound? Children?
Yes, teacher.
Okay. Here area, small area dA, area vector, outward drawn normal. Electric field positive charge. Electric field also outward drawn normal. So angle between them becomes 0. So E into integral dA. Integral dA is A. So E into A will be the flux through first surface. Similarly, second surface also E into A. So total flux passing through the two flat surfaces will be 2 into E into A. But you know, for the curved surface, flux equal to 0. Why curved surface flux equal to 0? I will ask to Barna Manoj. Why curved surface flux equal to 0? Barna Manoj. Barna. Why curved surface flux equal to 0? Ribangsha, can you tell? Curved surface, the flux is considered 0. Why? No answer. Manu Shankar, can you tell? Curved surface flux equal to 0. Why? ആരും പറയുന്നില്ല, എന്താണ് അവ ചെയ്യുന്നുണ്ടിരുന്നത്? നീരജ്, can you tell? Curved surface flux equal to 0. Flux formula EDS cos theta. Why the flux equal to 0 for the curved surface? Neeraj, no answer. Nena,
Yes, ma'am.
Neeraj, tell. Why curved surface we consider flux is 0? Curved surface, tell.
Angle 0 ആയിരുന്നല്ലോ.
Angle 0 ആണ്. നോക്കിയേ, ഇലക്ട്രിക് ഫീൽഡ് ഇങ്ങോട്ട് ഔട്ട്വേർഡ്, ഇവിടത്തെ ഒരു നോർമൽ വരച്ച് ഇങ്ങോട്ട് പോവുക. അപ്പം ആംഗിൾ എത്ര വരിക? 90 അല്ലേ വരിക? അപ്പം കോസ് 90 0 ആവണോണ്ടല്ലേ ഫ്ലക്സ് 0 ആവണേ. ഫ്ലക്സിന്റെ ഫോർമുല പറഞ്ഞേ? EDS ഫ്ലക്സിന്റെ ഫോർമുല പറ നീരജ്. അപ്പോൾ ഒന്നുമില്ല. ഇ ഡി എസ് കോസ് തീറ്റ, അതാണ് ഫ്ലക്സിന്റെ ഫോർമുല. ഇ ഡോട്ട് ഡി എസ്, ഇ ഡി എസ് കോസ് തീറ്റ. തീറ്റ 90 ആകുമ്പോൾ ദാറ്റ് ഫ്ലക്സ് ബിക്കം 0. ഇ ഡി എസ് കോസ് 90 ബിക്കം 0. അപ്പോൾ നീരജ്, why flux is 0 along the curved surface? Tell the answer. Theta?
Cos 90 is equal to 0. അത് തന്നെ.
So flux equal to EDS cos 90 becomes 0. Okay. Then total flux will be phi1 plus phi2 only. Phi3 becomes 0. So phi1 is equal to E into integral d phi1 is this. Therefore phi1 is integral d phi1. Therefore integral d phi1 will be E into integral dA is a area, this area. Integral dA is this area. Okay, you can see the steps.
Since E and dA are parallel to each other, E dot dA is equal to E dA cos 0, which is equal to E dA. Let this be equation 2. It is important to note that E is constant in magnitude for all points on S1. Now, phi 1 is equal to integral E dA. Since E is a constant, it is taken out of the integral. Then, phi 1 is equal to E into integral dA. Integral dA is equal to A, where A is the area of S1. Therefore, we get phi 1 is equal to EA. Since surface 2 is equivalent in all aspects to surface 1, the electric flux through surface 2, phi 2, is also equal to EA. Now consider surface 3, which is the curved surface of the Gaussian cylinder. At every point on the Gaussian cylinder, the electric field strength E and the outward normal to the surface, which represents the area vector, are perpendicular to each other. As the angle between the area vector and the direction of the electric field is 90 degrees, and as cos 90 degrees is 0,
ടീച്ചർ
Yes.
the flux phi
ടീച്ചർ വോളി ഒന്ന് കൂട്ടോ, കേൾക്കുന്നില്ല അങ്ങനെ.
Okay, നോക്കട്ടെ.
Ma'am, can you admit Devika?
ആര്?
Devika.
ദേവിക. Okay. See, I will explain then you will do it. Okay. So flux through this surface 1 and 2 is phi 1 and phi 2. That you know, it is E into A, E into A. So what will be the total? EA plus EA 2 EA. Phi 3. Phi 3 means flux through the curved surface of the cylinder. Here area vector is the red line, that is the area vector. Blue line, that is the electric field. Angle between them is 90 degree. So phi 3 becomes 0. E ds cos 90. Cos 90 is 0. So phi 3 is not there. Only the flux is crossing the flat surface only. So total flux equal to 2 into E into A. മനസ്സിലായോ അത്? Did you understand, children? Total flux through the Gaussian surface 2 into E into A. Please tell.
Ma'am,
Huh.
phi is equal to phi 1 plus phi 2 plus phi 3.
Ah.
So, phi 3
പ്രകാശം കേൾക്കുന്നില്ല. Phi 1 plus phi 2 plus phi 3. That means 3 surfaces are there, Gaussian cylinder. This is the cylinder is the Gaussian surface enclosing the charge. And here surface 1 is this flat surface. Surface 2, here also you will get a flat surface. and the curved surface. That is the third one. So flux through these three surfaces you have to find out. First surface phi 1 we got E into A, because E ds cos 0 it becomes area vector, electric field, both are in the same direction. So E ds cos 0, so we get cos 0 is 1. So E into dA, integral E into dA becomes E into A. Flux through the surface 1 E into A. Similarly, flux through the surface 2 also will be E into A, similar surface. So total flux will be E phi 1 plus phi 2 plus phi 3. But phi 3 we have to take 0 because angle between area vector and electric field is 90 degree. So E ds cos 90 it becomes, so that flux becomes 0. Phi 3 is 0. Clear, children? എത്ര തവണ പറഞ്ഞു എന്നിട്ട് മനസ്സിലായില്ലേ ഇത്? നല്ല കാര്യം.
Yes, ma'am.
മനസ്സിലായി എന്ന് വിചാരിക്കുന്നത്. ഓക്കെ, ടോട്ടൽ ഫ്ലക്സ് ഈസ് 2 into E into A. That is equal to Q by epsilon 0 according to Gauss's theorem.
Is equal to E dA cos 90, which is equal to 0. Hence, no flux passes through this surface. Thus, the flux phi 3 through this surface is 0. Substituting the values of phi 1, phi 2, phi 3 in the expression for total flux phi, we get phi equal to 2EA. Let this be equation 3. According to Gauss law, phi is equal to Q in by epsilon naught. Substituting the value of
Gauss's
Q in,
theorem.
we get phi is equal to sigma A by epsilon naught. Let this be equation 4. From the equations 3 and 4, we get 2EA equal to sigma A by epsilon naught. Simplifying this expression, we get E equal to sigma by 2 epsilon naught. Let this be equation 5. The expression for the electric field due to the infinite plane sheet of charge shows that the electric field strength due to it is independent of x.
Yes.
Pictorially, E is equal to sigma by 2 epsilon naught into n cap, where n cap is the unit vector perpendicular to the plane and passing away from it.
Okay, children. So here, this derivation is very, very important. And I have sent you some questions from previous year's question papers, and in that you can see this derivation. What's the question? State Gauss's law, derive the expression for electric field due to a thin, infinite plane sheet of charge. That is the question related to it. Electric field due to a thin plane sheet of charge, infinite sheet. So this is the question, and this is the final expression for it. How you derive? First find flux through all the three surface and curved surface flux is 0. ഇതൊക്കെ പഠിച്ചു കഴിയുമ്പോൾ നിങ്ങൾക്ക് തന്നെ ഓർമ്മ വരണം. Flux through curved surface 0 because theta is 90. The other surface constitute flux here. Flux equal to 2 into E into A. Then we know flux according to Gauss's theorem, flux is Q by epsilon 0. Q is equal to sigma A, charge of this much area, sigma A, this much area, sigma A by epsilon, charge enclosed, this much charge only encloses this area, charge enclosed by the area, sigma A by epsilon 0. Flux equal to sigma by A by epsilon 0, flux equal to 2 into E into A. So we can equate, left sides are equal, we can equate them. 2 into E into A equal to sigma A by epsilon 0. Therefore, E equal to sigma A and A cancelled. Sigma by 2 epsilon 0. And as a vector quantity, when we write, vector E is equal to sigma by 2 epsilon 0 into n cap. N cap is the unit vector in the direction of electric field. Okay. So So this is the final magnitude, and this is the vector, electric field vector. So here, this expression shows, sigma is surface charge density, charge per unit area. Epsilon 0 is the permittivity of the medium, free space. And so it is not depending upon the distance. See, whether it is at a distance 1 meter or 2 meter, that electric field is not depending on that. It depends only on sigma and the medium where it is kept. Understand? Sigma by 2 epsilon 0, by heart this expression. At any time, when I ask, you should be able to tell this. Understand? Derivation also, write and study. That is the only method. First understand the things, then write and study. That is the only method to remember things. No shortcuts for this. Just write and study. Okay. So what is the expression? Sigma by 2 epsilon 0. It is independent of the distance of the point from the sheet. Okay. So with that, now we have to, that derivations are over, but some special cases we have to discuss. That we can discuss in our notes. Okay. This one. Okay. Yeah. This is last one. What you want to tell me? Huh? I am not able to hear. Derivation, so many derivations and formula that formulas all I have written and I will send to you. You have to by heart all the formulas, all the derivations, and that's why that is what I told. Many will be there in each chapter, and you have to remember all those things. Our page is in sheet of charge. I have written all the formulas and I will send to you for making your study easy. I have collected the formulas. Okay? I will send to you after the class. You can write in your notebook and study. Sigma by epsilon 0. So this is what we have done. 2 into A, EA equal to sigma by epsilon 0. Then A get cancelled. We get E equal to sigma by 2 epsilon 0. This is what we have done. Next is electric field electric field intensity due to thick sheet of charge. We have discussed the thin sheet of charge. And if the sheet is thick, just like a book, you see, if it is thick, tell me.
No, I love field points, normal.
Notes പറഞ്ഞല്ല നോട്ട്സ് ആണോ
ഈ ഭാഗം the field point normally away from the plane.
ഇതിലത്തെ നോട്ട്സ് നോക്കിയിട്ട് പറയണോ
അല്ല മാം നോട്ട് കൊടുത്തിട്ടില്ലേ ഇതില്
അത് നോക്കിയിട്ട് പറയണം അല്ലേ എക്സ്പ്ലെയിൻ ചെയ്യാം അല്ലേ ഓക്കെ ഇതല്ലേ പറഞ്ഞേ
ടീച്ചർ അതിൽ നോട്ടില്ലേ നോട്ടായിട്ട് കൊടുത്തിട്ടില്ലേ
അതല്ലേ ഓക്കെ E is independent of R. There is no R in this expression. The electric field is independent of R. The distance from R, the distance from the plane sheet. E is independent of R, the distance from the plane sheet. The field points normally away from the plane sheet. We told electric field positive charge, positive distribution is positive charge. Positive charge is distributed on the sheet. So direction is away from the sheet, outwards from the sheet, away from the plane sheet on both sides. It will be on both sides. If sigma is greater than 0, that means positive. Greater than 0 means positive. It will be outwards. And if it is negative charged sheet, field will be inwards. Less than 0. Sigma less than 0 means if the charged sheet is negatively charged, field will be inwards. If it is positively charged, field will be outwards. And the electric field intensity is independent of the distance r from the sheet. Okay, clear now, Mitra?
Yes, madam.
Okay. Then electric field intensity due to a thick sheet of charge, infinite itself, thick sheet of charge. So, what is the difference between thin sheet and thick sheet? Thick sheet, you know, this field and the other surface also there is a surface, charged surface, that field also we have to consider. So, when you consider a point here, see, when you consider a point, right side of the sheet, if you consider a point P here, the electric field first due to this sheet, and another field also will be there due to the other sheet which is behind it. This is a thick sheet. So, behind it is also having a sheet and it is uniformly charged. So, due to both the sheets, there will be electric field at this point, and as they are positive, both are positively charged sheet, it will be outwards, and the sum of the field only we will be getting at the point P. At the electric field intensity at point P will be due to both the sheets, this sheet and the sheet behind it. So, sum of the electric field, net field will be sum of the electric field, E1 plus E2, that is net field. E1 plus E2 you have to find out. Okay. E1 is sigma by epsilon 2 epsilon 0. E2 also that will be sigma by 2 epsilon 0. So, you add that. So, you will get net electric field. Is written. Yes. Sigma by 2 epsilon 0 plus sigma by 2 epsilon 0. That is 2 sigma by 2 epsilon 0. 2 and 2 get cancelled and we get sigma by epsilon 0. For a thick sheet, electric field is sigma by epsilon 0. That is one special case. And another special case, you see, electric field intensity due to two thin infinite parallel sheets of charge. Two thin infinite parallel sheets of charge. So, when you keep two sheets here, it divides this area into three regions. That means in between the two sheets, one region, left side of the sheet, one region, right side of the sheet be another region, three regions. When you keep two sheets here, divide the space into three regions, left side of the sheet A, right side of the sheet B, and in between the two sheets. So like that, three regions are created. And here, left side, let us consider left side, both are positive charge. So, electric field will be outwards. So, here in region 1, the electric field is due to both the sheet and it is away from it, outwards. So, net field will be E1 plus E2. Here also, the region 3 also electric field will be due to both the sheets and both are outwards. So, here also field will be E1 plus E2. But in between this, you see, electric field due to the sheet A, E1, right side, E1, vector E1, right side. Electric field due to sheet B, that will be positive charge, you know, that will be towards left side, E2. E2 is towards left side, E1 is towards right side. So, the net field will be of my E1 minus E2. If they are equal, then it will be 0. Then if they are equally charged, sigma, both are same, then it will be cancelled. But if one is greater in that direction, the net field will be in the direction of greater field. Okay, that is the special case discussions. So here you can see sigma 1 uniform surface charge density of A. This is sigma 1. This is sigma 2 surface charge density of the sheet 2, sigma 2. So, E1 is sigma 1 by 2 epsilon 0, sigma 1 by 2 epsilon 0, E2 sigma 2 by 2 epsilon 0, different surface charge density. So, E1 plus E2, first in region 1 we can find out. Electric field intensity in region 1 is left side we have taken minus In region 1, it is left side of the sheet A. Both left side we take minus, right side we take plus. So left side, as it is left side, minus E1 minus E2. So minus sigma 1 by 2 epsilon 0 minus sigma 2 by 2 epsilon 0. So common factor is taken outside, minus of 1 by 2 epsilon 0. Inside the bracket, sigma 1 plus sigma 2. Okay. Next, region 2, E1 minus it, I told E1 is right side, E2 is left side, net field will be E1 minus E2. So 1 by 2 epsilon 0, sigma 1 minus sigma 2. In region 3, it will be both are towards right. So you have to add E1 plus E2, sigma 1 by 2 epsilon 0 plus sigma 2 by 2 epsilon 0. So 1 by 2 epsilon 0 into sigma 1 plus sigma 2. So these are the special cases. Okay, and one more, in that one more special case comes. If sigma 1 is plus sigma and sigma 2 is minus sigma, what will be the field? One is positively charged, other is negatively charged equally. One is plus sigma, other is minus sigma. What is the electric field? That case E1, we can substitute E1. One is plus sigma, other is minus sigma. What it becomes? Plus sigma minus sigma adding 0. So E1 is 0. Similarly, E3 also plus sigma minus sigma, that will be 0. But you know, electric field in the middle region will be sigma 1 minus minus sigma, sigma plus sigma, 2 sigma by 2 epsilon 0. 2 and 2 get cancelled. We get sigma by epsilon 0, which is a constant value, not varying with distance. So if you keep two sheets, one is plus sigma and other is minus sigma, in this region, middle region, electric field is sigma by epsilon 0. Very important result. Very, very important result. When one sheet is plus sigma, other sheet is minus sigma, electric field between the two sheets is sigma by epsilon 0. That is the result we use in capacitor, you know. And here, region 3 it is 0, region 1 also electric field 0. When one is plus sigma, other is minus sigma. What is the electric field between the region, children? Pavitra, what is the electric field between the two regions? One is plus sigma, other is minus sigma. What is the electric field?
0.
Is it 0? That is what I told. Krishna Sri, what is the electric field between the two regions? Between the two regions.
That sigma by 2 epsilon 0.
Sigma by epsilon 0. Here it is 0, Pavitra. Even this region 1 and region 3, it is 0. But in between that, it is sigma by epsilon 0. That is what we have seen. In that, see, here I showed you now, between the region, that is region 2, one is plus sigma, other is minus sigma. Sigma minus sigma, sigma plus sigma, that is 2 sigma by 2 epsilon 0, 2 and 2 cancel, we get sigma by epsilon 0. So electric field in region 2 becomes sigma by epsilon 0. That is a constant value. So the electric field becomes constant. That is a very important result. How will you produce a uniform electric field? How will you produce a uniform electric field? Children, how will you produce a uniform electric field? I'm sorry. Nana, how will you produce a uniform electric field? Nana, take two thin sheets. One is plus sigma, surface charge density. Other is minus sigma, surface charge density. Then the electric field between the two sheets will be uniform. What is its magnitude? Sigma by epsilon 0. Nana is not answering. I answered.